Problem 2-51. Represent the number you would have to add to an expression of the form x squared plus bx to make a complete square. All right, so we've looked at doing this several times here in class. We've got x squared plus, and let's just use a real example here first. So if we have x squared plus 6x plus blank, and we were taking it and you were using, whether you're using the generic rectangle or you're just using two sets of parentheses for your binomials, you know that when you factor it, you're going to end up, having a binomial that starts with x and both of them there. And let's actually put that in here. We've got an x here and an x here. And then we would have had 6x. So since this is a perfect square, we would have had 3x's up here and 3x's over here, which then would have meant that we would have had to have multiplied x times 3 to get that 3x, and the same thing over here, which means we'd have a 3 here and a 3 here, and they're actually both positive. So the last missing part of this is what's up here. But now that we know the dimensions, we could do 3 times 3 and get 9 up here. So we would have to add 9 up here. That's what makes the perfect square trinomial. But if you notice what these numbers have in common here, like if we multiply 3 times 3, we get 9. That's the same thing as 3 squared. We get 9. Also notice here that 3 is half of 6 because we took this middle term and we split it in half. So as we look at the problem that they've given us, just the model x squared plus bx plus blank, we know that this term would have to be split into two parts. So we need to take our b and we need to divide it by 2. And after we took that, we would have ended up with our outer parts of our box, or the dimensions out here. And we took those and multiplied them by each other to get this number. And since they were the same, it's the same thing as squaring it. So we're going to take half of the middle term and we're going to square it. So we get b over 2 squared. Or if you actually square it, you would get b squared over 4. Actually, let's put both of them there because I prefer the one on the right here, the b over 2 squared, but I know the book prefers this one. So if you just want to see a practice one, let's see, if we had x squared, and let's say we had minus 10x plus blank, and we were trying to fill it in, well, if we took this and we broke it in half, we'd have negative 10 divided by 2. That would give us negative 5x's up here and over here. So negative 10 divided by 2 is going to be negative 5. And when we square that, that's going to give us 25. So we're going to be adding 25 into here. And if you look, that's the same thing as saying negative 10 squared divided by 4. If you say negative 10 squared divided by 4, that's 100 divided by 4, which is 25 also. Do one more here. Let's say x squared, and let's do plus, and let's put a decimal in this one. Let's make it an odd number. So let's do plus 9x plus blank. If you've got an odd number here, the easiest way to do it is just to do the same thing. Take 9, we're going to divide it by 2, so it's in fraction form now. Just don't even worry about turning it into a decimal. It's just one more extra challenge for you as you take it and square it. It's probably easier for you to square 9 and square 2 than it is to square 4.5. So 9 squared gives us 81 in the numerator. And 2 squared gives us 4. So we end up with x squared plus 9x plus 81 fourths, which is the same thing as 20 1/4 if you were looking at it. But this would be what we're looking for as the answer to this problem right here. Either one of those would work. This is problem 2-51. Hopefully that helped make sense of this if you had a question. If not, please make sure you ask your teacher. Thanks for watching.